This is experiment 6, parallel circuits. And here we are going to measure the parallel circuit's resistance and also the voltage across every resistor. And we're supposed to measure the current also. For this experiment, I will demonstrate everything besides measure current. By this point, all of us should know how to measure current. So I just skip that step. So here, this is page number 4. As always, we need to measure the resistance for each of the required resistors. So for this experiment, we need 220 ohm resistor, 100 ohm, 330 ohm. If you don't have that, can replace this by a 300 ohm. And then we use a 1 kilo ohm resistor. These are the measured values, the one I measured using multimeter. And then now here is that circuit. This is the one. This is the circuit at the end, the one with all these 4 resistors connected in parallel. If you want to look at the figure, that is on page number 5. This is the one with R1, R2, R3, R4. I follow the order of the resistors shown in the figure to build this circuit, which is important. But if we need to begin from step 2, the first step, which is here, we need to have a circuit with 2 parallel resistors. They are R1, R2. So for your case, you don't have to build all and then disassemble, remove the parts. You can just begin with circuits with 2 resistors. They are R1, R2, this one, that one. So to show the case, I'm going to disconnect that resistor, put that here, and then this is the third R3. The other one, the one I just unplugged, is R4. This is R3, R4. So at the beginning, we just need resistor R1, R2. What we need to do just to measure the resistance in this step. So take the multimeter, make sure it's switched to the ohm meter mode, and then I will connect here this probe to there, and then this probe to here just to measure the resistance. 69.0 or 69.1 ohm. That is the resistance of this parallel circuit, the circuit with R1 and R2 only. So 69.1. I will write this down. I will write down the number over here. Table 6-2. This is one R1, R2 connected in parallel. The measured number is 69.1 ohm. And the next step, we need to connect the source. We need to connect the source to here, the circuit. Connect the source to here, there. Connect the source here, or the other side of the terminal, the other terminal over here. And now the circuit has the source connected. We can do a verification just to verify the knowledge we learned. That is, both resistors should have the same voltage. So I will connect that over here. The meter has switched to the DC voltmeter mode already. And what I need to do is just to poke this probe to the other side of a resistor, 8.32 volt. And how about that one? 8.31 volt. So both resistors, each one takes, right, each one has the total source voltage. This 9 volt battery now is reduced to 8.31 volt or 8.27 volt, same as the other resistor. So this verified that concept we learned For parallel circuit, every branch has same voltage. But for the next step, let me disconnect here first. For the next step, we need to measure the current flow into the circuit from here all the way to there. Right? Once we have the source connected, we need to use the meter, switch the meter to the DC current mode and measure the current with the source connected. I leave that to everyone. I leave this to you. And so I won't demonstrate this step. We should all know how to do it. And then once you measure the number, make sure record that number over here. This is the current, the total current for the circuit with only R1 and R2 connected. They're connected in parallel. Next, I'm going to connect the third resistor, R3. R3 is 330 ohm, orange, brown. So I will put that here. Just take the tweezer and then put that over here. As you can see, I already have the wires connected. Just insert the resistors. So 3 resistors, R1, R2, R3 connected in parallel. The gap here separate the two sides of each resistor. And now we're gonna do the same thing. We just repeat the steps, but measure the same thing for different circuits. Each circuit has additional resistor. Switch to the ohm mode and measure the resistance of that circuit. Just like before, I put the clip here and then poke to the other side of the circuit. Before taking a measurement, we can predict, based on the knowledge we learned, we can predict this time the resistance should be smaller than the circuit, the parallel circuit with 2 resistors connected. Since we add one more parallel branch, the total resistance should be decreased. Previously, with 2 resistors connected in parallel, the value is 69.1 ohm. Now the number here with 3 resistors connected in parallel, it should be less than that. Let's verify it. So I poke that here, 56.8 ohm. Okay, so write it down. The total resistance is 56.8 ohm. And we can do the same thing and measure the voltage from here to there. Or for every resistor, the voltage should be same. It's the same voltage for every branch because all 3 resistors connected in parallel. You can do the steps just to verify, to reinforce the learning, to validate the theory works. But we are not going to show that in this demo. That's a pretty simple step, just like the one we did before for the first circuit. And then we need to measure the current, right? Connect the source to the circuit, and then measure the current that goes through here. This is the main branch. The current going through this main branch from the source, right? With the source connected, the current go through here is the main branch current. In this case, it's IT, but for 3 parallel resistor circuit. So one more time, we are not going to demo that in the demo because everyone should know how to measure current. Next, let's move to the fourth circuit. So fourth one, we need to add one more resistor. That is the 1 kilo ohm. 1 kilo ohm resistor. That is here, which is the brown, black, red. So I put that over here. There we go. So now we have the circuit, right? This is the final circuit with 4 resistors connected in parallel. Let's do the same thing again, measure the total resistance. Since one more resistor is being added to the previous circuit, the new circuit should have less resistance. In other words, this is the smallest resistance among all 3 circuits here. 53.7 ohm. So let's write this down. 53.7 ohm. It is the resistance reduced. And then next we need to connect the source to here, and then use the meter to measure the current that flows to the circuit. It is the current in the main branch. We skip that step. Once you have that measurement, make sure you have this entry field, and also that entry field. As you can see, we skipped the first one. The first one is pretty simple. It's just the circuit without the 3, which means we unplug all 3, only 1 resistor is in the circuit. And that value should equal to R1, which is 221.3 ohm. 221.3 ohm. Make sure to measure the current flows in that circuit. The goal is here. We learn how to measure the total resistance of parallel circuits. There are 3 parallel circuits. We also verify as more resistors added into the circuit, more parallel branches added into the circuit, the total resistance of the circuit decreases. So that's the goal over here. Next, let's see. The remaining steps are just calculations. And then we have a evaluation and review questions. So this is the end of experiment 6. We did it relatively fast. The reason is we skipped the steps for measuring the current for every circuit.